Hello and welcome. So, given a circle, center L, and tangent line, various lengths, find the specified information. So we're told that D to H is 12, we can see that in our diagram there, and Y to H, that little section there, is 2. So what we're given, we can see on the diagram. Now keep in mind it said that we had a tangent line to the circle, which is going to be that line right there in yellow. Now what a tangent line is something that intersects an object at one place, that place being that point D right there. I'm going to get rid of the rest of those highlights so you can see it. Point D, we call it the point of tangency, as where the tangent line intersects the circle at its single place, right? So you'd say, all right, well, how is that helpful, knowing that we have a tangent line? Well, once we know it's a tangent line to the circle, we have this really cool property that any radius, so center to circumference radius, intersects a tangent line at a 90-degree angle. And this is really important because then that forms not only a triangle, but specifically a right triangle, which means that we're going to be able to use Pythagorean theorem for this thing. And Pythagorean theorem is that we have the leg of the right triangle plus the other leg equals the hypotenuse, and they all have squares. Alright, so leg squared plus the other leg squared equals hypotenuse squared. Now, on this one, just be aware, right, a hypotenuse to a triangle, any right triangle is going to be across from the right angle. So this is your hypotenuse, and then the two legs are going to be the L to D and the D to H segments. Okay, so how can we use Pythagorean theorem to help us here? Well, think about it. We have at least one leg, right, that's 12 squared, plus, do we know what the other leg is? No, we don't. But that's okay, right? We know that this is going to be a radius, right? Well, question, if this is a radius from L to D, what's the distance from L to Y? Isn't that also just a radius? Right? So that actually tells us both our other leg, that's going to be our radius squared, and we're also going to know our hypotenuse, because that's our radius plus the 2, right? That whole thing combined is our hypotenuse. That means we have r plus 2 squared. Alright, now this one, we have to be a little careful on this, is when we are dealing with a square, remember that means that you have two of the same parentheses. That's r plus 2 times r plus 2. Then we have r squared plus, and then 144 is 12 squared. Okay, and then you have to distribute this to get your correct answer. So then we'd say, alright, so distribute r times r squared, r times 2, 2r, 2 times r, 2r, 2 times 2, 4. So then we have r squared and 144 on the left, r squared plus 2r plus 2r plus 4 on the right. Okay, now if we wanted to start getting all of our r's together, right, I'd subtract my r squared, move it left to right, but you'll notice something interesting happens. As we move it, you'll notice on the left that's gone, right? It's 1r squared minus r squared, that's just 0. On the right side, they also cancel out, right? 1 minus 1, it's gone. And then we're left with 144 equals, I'm going to combine our like terms, 4r plus 4. Bam. Now this is way more manageable because now you don't have to worry about factoring or anything else, right? This is just a linear equation. We end up with 140 equals 4r, and then you would divide by 4 in order to get your final answer. So your r, the radius of this circle, is 140 over 4. Now you got to be careful. It's not looking for just an exact answer. It's not looking for just any fraction. It's looking for a simplified fraction as your answer here. So yes, 140 over 4 is correct, but you do need to simplify that. Okay, and if you actually do 140 and divide by 4, that's actually a whole number. That's 35, right? So that means our radius is 35. There you go. Okay, and if we wanted to find the hypotenuse, right, this L to H segment, that'd be 35 plus 2, which would be 37. All right, and there you have it. And that'd be your answer. Thanks for watching.